In this video, we will discuss about some important problems on inverse trigonometric functions. Here, we are going to solve 3 to 4 types of important problems. So let's get started with the first problem. It says, show that sine inverse of 2x into root of 1 minus x square is equal to 2 sine inverse x. X lies between minus 1 by root 2 plus 1 by root 2. So in such problems, of course, in most of the problems in inverse trigonometric functions, what we do is we will do the substitution method. We have to substitute an appropriate value to x so that this whole term will be simplified. So in this problem, if we substitute x is equal to sine theta, then as we know, sine inverse of x will become theta. And if I take LHS, which is sine inverse of 2x into root of 1 minus x square, that will be equal to sine inverse of 2 into x is nothing but sine theta into root of 1 minus x square. X square is nothing but sine square theta. But we know that 1 minus sine square theta is cos square theta, and if I take the square root, that will become cos theta. So the whole term will be 2 sine theta into cos theta. But we know this formula, 2 sine theta cos theta is nothing but sine of 2 theta. And we also know that sine inverse of sine 2 theta is 2 theta, because we know that sine inverse of sine x is equal to x. Therefore, this is 2 theta. But theta is nothing but sine inverse x. Therefore, the answer will be 2 sine inverse x, which is the required result. Similarly, we can prove one more. Sine inverse of 2x into root of 1 minus x square is equal to 2 cos inverse x. Same thing, but what we do is, instead of substituting x is equal to sine theta, we will substitute x is equal to cos theta and proceed similar to this. I hope you can do it. Now, moving to the second problem. Show that tan inverse of 1 by 2 plus tan inverse of 2 by 11 is equal to tan inverse of 3 by 4. We heard a formula, or we derived a formula in the last video, which says tan inverse x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus xy. This problem uses this formula. Now observe, just compare LHS of formula and LHS of problem. Instead of x we have 1 by 2, instead of y we have 2 by 11. Therefore, we can solve this problem using the formula. So this will become, we have to replace x by 1 by 2 and y by 2 by 11 in this problem, and that will be tan inverse of 1 by 2 plus 2 by 11 divided by 1 minus 1 by 2 into 2 by 11. We have to simplify this. You know, you have to take LCM and simplify the numerator, and you will multiply and simplify the denominator. When you do that, you get it as tan inverse 15 by 20. And 15 by 20 can be further simplified to 3 by 4, and that is our required RHS. Moving to the next problem. Now observe this problem. We have to prove 2 tan inverse 1 by 2 plus tan inverse 1 by 7. Most of the students make a mistake here. What they do is, they will forget 2 and they directly use the formula which we have used in the last problem, but that's not the right way. What we have to do is, we have to first simplify 2 tan inverse 1 by 2. We had a formula 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. So we have to use this formula to simplify this first term. Therefore, 2 tan inverse 1 by 2 is, what we have to do is, in the formula we have to replace x by 1 by 2. Then we get it as tan inverse of 2 into 1 by 2 divided by 1 minus 1 by 2 whole square. 2 to get cancels, we get the numerator as 1, but here it will be 1 by 4. 1 minus 1 by 4 is 3 by 4, and when you take the reciprocal, you get it as tan inverse of 4 by 3. Now we have to use our previous formula, which is the formula for tan inverse x plus tan inverse y, and the LHS now will become 2 tan inverse 1 by 2, we have found it to be tan inverse 4 by 3, and tan inverse 1 by 7 as it is. And proceeding similar to the last problem, we get it as tan inverse of 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. That will be tan inverse 31 by 17, and that will be the required RHS. Next problem. Prove that tan inverse x plus tan inverse 2x by 1 minus x square is equal to tan inverse of 3x minus x cube by 1 minus 3x square, where x or mod x less than 1 by root 3. Here we will substitute x is equal to tan theta, and we know that when x is equal to tan theta, theta will be tan inverse x. And we will take the RHS instead of LHS because that will be the easy method. So when you take RHS, we know the RHS is tan inverse 3x minus x cube by 1 minus 3x square, and that will be equal to tan inverse of x is nothing but tan theta. So 3 tan theta minus tan cube theta by 1 minus 3 tan square theta, and that will be tan inverse of, you know this formula, this is the formula for tan of 3 theta. We have studied this in the first year trigonometry. So tan inverse of tan 3 theta, as you know, will be 3 theta, but theta is nothing but tan inverse x, so this is 3 tan inverse x. But look at the LHS. LHS is not the same, so we have to further simplify this. You can see 1 tan inverse x here, so I can write 3 tan inverse x as tan inverse x plus 2 tan inverse x. Now, no problem with the tan inverse x, that's there in the answer, but look at the second term. It is tan inverse of 2x minus 1 by x square, but here it is 2 tan inverse x, but we know that they are same because we have a formula 2 tan inverse x is equal to tan inverse of 2x minus 1 by x square. So that will be the LHS, and that's the answer. Next problem. Prove that 3 sin inverse x is equal to sin inverse of 3x minus 4x cube. What we do here is we will take x is equal to sin theta, then sin inverse x will be equal to theta, and we take the RHS. Now, what is RHS? RHS is sin inverse of 3x minus 4x cube, and when you substitute, we will get it as sin inverse of 3, x is sin theta, minus 4 into x cube is sin cube theta. We have seen this somewhere, right? This is nothing but the formula for sin of 3 theta, and sin inverse of sin 3 theta is nothing but 3 theta. And what is theta? Theta is nothing but sin inverse x. Therefore, we get the answer as 3 sin inverse x, and that will be the LHS. So this is the next type of problem. This is also one of the important type. You have to write the functions in the simplest form. What we have to do is we have to simplify the question to a simplified form. There are 2 to 3 ideas. One method is, as we know, by substitution, and some of the problems can be simplified without substitution also. But for this problem, we have to substitute. What we do is we will put x is equal to tan theta. Then, as we know, theta is tan inverse x. So the problem will become tan inverse of root of 1 minus x square minus 1 by x. That will be equal to root of 1 plus x square is tan square theta minus 1, x is tan theta. And we know that 1 plus tan square theta is secant square theta, and its root is secant theta minus 1 by tan theta, and we can write it as secant theta is 1 by cos theta, tan theta is sin theta by cos theta. So when you simplify, we get it as 1 minus cos theta by sin theta. And we know that cos 2x is 1 minus 2 sin square x. So 2 sin square x, when you simplify this, we get it as 1 minus cos 2x, but we have 1 minus cos theta here. So when you use the half angle formula, we get it as 2 sin square x by 2. That means when you divide x by 2, both the sides, we get it as 1 minus cos x. And similarly, sin 2x is 2 sin x cos x. So sin x will be 2 sin square x by 2 cos x by 2. 2 sin x by 2 cos x by 2. I use this here. Instead of 1 minus cos theta, I use this. Instead of sin theta, I use this. So I will get it as 2 sin square theta by 2. And sin theta is 2 sin theta by 2 cos theta by 2. 1 sin get cancels, 2 get cancelled. So we are left out with sin theta by 2 by cos theta by 2, which is tan theta by 2. And that will be tan inverse tan. So it is theta by 2, or it is 1 by 2 tan inverse x. So the next problem. Tan inverse of 1 by root of x square minus 1. Here we will substitute x is equal to cosec theta. Then, as you know, theta will be cosec inverse x. Then tan inverse of 1 by root of x square minus 1 is equal to tan inverse of 1 by root of x square is cosec square theta minus 1. And we know that cosec square theta minus 1 is cot theta, and when you take the square root, it will be cot theta. This is cot square. When you take the root, it will be cot. And we know 1 by cot is nothing but tan, and tan inverse of tan theta is nothing but theta, and theta is cosec inverse x. But when you look at the answer, we may have two options, either cosec inverse x or pi by 2 minus secant inverse x. As you know, cosec inverse x, which is also equal to pi by 2 minus secant inverse x, because cosec inverse x plus secant inverse x is equal to pi by 2. We have proved this in the last video. Next problem. Tan inverse of cos x minus sin x by cos x plus sin x, where x lies between 0 and pi. Here there is no need of substitution because we already have cos and sin. So what we do is we will divide both numerator and denominator by cos x. So cos x by cos x is 1, sin by cos x by cos x is 1, sin by cos x. Or this will be 1 minus sin x by cos x is tan x, and sin x by cos x again tan x. So that whole term will become 1 minus tan x by 1 plus tan x. Or this is nothing but tan inverse of, as you can see, we can write it as tan inverse 1 minus tan inverse of tan x, because when you simplify this, you get it as tan inverse of 1 minus tan x by 1 plus 1 into tan x, which is tan x. So this is further simplified. Tan inverse of 1 is nothing but pi by 4, because tan of 45 degrees is 1, and tan inverse of tan x is nothing but x. So it is pi by 4 minus x. Next problem, tan inverse of 3a square x minus x cube by a cube minus 3ax square. Of course, here we have to substitute. We have to put x is equal to a tan theta. Why a tan theta will be a question. See, when you substitute something, we have to choose the function very carefully. Here we have already a. So a should be cancelled to simplify this. If you want to cancel a, when we substitute, we have to take a together. So whenever we have in terms with a, we have to substitute it as a into the function. Here it is a into tan theta. And when you simplify, x by a is tan theta, and theta will be tan inverse x by a. Then tan inverse of 3a square x minus x cube by a cube minus 3ax square will be tan inverse of 3a square as it is. X is a tan theta. X cube is a cube tan cube theta. A cube as it is. 3ax square is 3a into a square into tan square theta. And when you simplify this, a square into a is a cube, tan theta as it is, this term as it is. Here again a into a square is a cube. Now as you can see, 3a cube can be taken outside. Here also we can take a cube outside. So when you take a cube outside both the side, that will be get cancels. So we are left out with 3 tan theta minus tan cube theta by 1 minus 3 tan square theta, which is nothing but the formula of tan 3 theta. So the answer will be 3 theta, which is nothing but 3 tan inverse x by a. Now let's see one more type of problem which says find the value of tan of half into one term, which is sin inverse 2x by 1 plus x square, and the other term is cos inverse of 1 minus y square by 1 plus y square. What we do is we will see the terms one by one. First let's see sin inverse 2x by 1 plus x square, where I will put x is equal to tan theta. Then theta is tan inverse x. Then this term will be sin inverse of 2 tan theta by 1 plus tan square theta. And we know that this is the formula for sin 2 theta. And when you simplify, you get it as 2 theta. And theta is nothing but tan inverse x. So the whole term will be 2 tan inverse x. Similarly, when you look at the second term, I will put y is equal to some tan pi, some other angle. Then pi will be tan inverse of y. Therefore, cos inverse of 1 minus y square by 1 plus y square will be cos inverse of 1 minus tan square pi by 1 plus tan square pi, which is cos inverse of cos of 2 pi. This is the formula for cos 2 pi, and that will be 2 pi, and pi is nothing but tan inverse phi. So first term is simplified to 2 tan inverse x, and the second term is simplified to 2 tan inverse y. Now when I take the whole term, that will be tan inverse of half into, first term is 2 tan inverse x, second term is 2 tan inverse y, that will be tan of. Now as you can observe, here half, and when you take 2 common from these two terms, 2 and 2 get cancels, we are left out with tan inverse x plus tan inverse y, which is nothing but tan inverse of x plus y by 1 minus xy, and that is x plus y divided by 1 minus xy. That will be the final answer. Now look at this problem. Most of the students tend to do mistakes here because this is not to prove, this is to solve. There is a difference between solving and proving. Whenever they ask for to prove, we have to prove LHS is equal to RHS or vice versa. But when they ask for solve, the idea is we have to take the whole equation and we have to find the value of x. So what we do here is we will take the whole equation and we are going to simplify this. How will you simplify? We will take the formula of tan inverse x plus tan inverse y, that is tan inverse of x plus y, but in the place of x it is 2x, in the place of y is 3x. So this will be the simplified version. 2x plus 3x is 5x, 1 minus 2x into 3x is 6x square, and I will take tan to the right side. That will be tan pi by 4, and we know that tan of pi by 4 is 1. Now, when you simplify it further, we get it as 6x square plus 5x minus 1. When you simplify this, when you take this term to the right and when you simplify, and we can further factorize it to get 6x minus 1 into x plus 1 is 0. So the value of x is either 1 by 6 or minus 1. But we cannot take the x value as minus 1, because when you take x as minus 1, this will be a negative value. This is also negative value. So the whole LHS is negative, but RHS is positive. So we cannot take x is equal to minus 1 as a value. So obviously x is equal to 1 by 6 will be the answer. I have tried to cover almost all types of problems. I have not solved all the problems, but all types of problems. So if you have any doubts or any new ideas, please put it in the comment below, and don't forget to like, share and subscribe to